Hi, in this tutorial, we're going to learn how to produce digital and instant construction quantities and schedules. In this project, let's have a look at what items of work we got in this one, so called quantification. As we can see here, there was nothing when we started the job, only the existing ground surface, which is something like this in this picture, or the next one as well. That's for just an example about the ground conditions when the operator took possession of the construction site. Before we start quantification, let's have a look at a typical example of the bill of quantity in what these items are providing, or we have to fill these schedules with the quantities. The first item of work which is required quantification is excavating topsoil, this item. But this item is the level 3 of this combination of text. So with the bill of quantities, you got level 1, level 2, level 3, level 4, level 5, which is the subsection, major heading, general heading, and you got the comment, and the final one is the price item. We are interested in this item 150. The unit of measurement for this item is square meter. While we see when it comes to the excavation below the level of the topsoil, where we are cutting down, or whether it's cut or fill to formation level, will be worked. The unit of measurement is with cubic meters, and similarly with foundations of the pad foundations or beams, all with the cubic meters or with tonnage. In this project, we're going to use cubic meters and tonnage in our measurement for earthworks, concrete, and rebar. What we have got here, we have got an existing survey to the area where the construction of the tank is taking place, and we have created a surface. So let's have a look at the 3D of this surface here and see what it looks like. So to start with, we got now, let's say this surface here. I don't know if you can see it clearly the way I see it. So this is the shape of the existing surface where the construction process we're going to start in this area. So to start with working out digitally the volume of the topsoil, first let's have a look at in cross section about how we're going to achieve that. So let's say quickly now, let's say we have this, let's say we got this is the terrain of the existing ground surface. It will be wrong to work out 150 from the ground surface not following the ground terrain, ground profile. So it is wrong to work out something like that. But the right one is when we try to follow the same ground surface with 150. So the question is how we gonna achieve that? Well, we can achieve that by, first of all, let's take off this one here, and we try to illustrate this in a different way. So let's say this is exactly the same now, the same terrain profile, and then we need to take off 150 from the top existing ground level. We take 150 exactly the same terrain and the same terrain profile. Okay, so how are we gonna do that? We can do that is by going back to our model here, as we said, this is the surface of the existing ground level. We will create another surface which is 150 below this surface. So what we do is we create now another surface. Let's say create another surface, and we call it existing. We call it existing minus 150. So we go back there, and okay, so we created another surface now, which is exactly the same, but I need to make this surface is 150 less than the original surface. I could do that by going to the surface. I go to the surface now, and when we do the surface, we can go now and lower it by, so it's minus 4.150. So now I got two surfaces, one 150 less than the other. Let's have a look at now. Let's have a look at now about there's two of them, the two surfaces, what they look like in 3D for us to visualize and see whether we are getting there. As you see here, we have created the same terrain, but with 150 difference between them. Exactly the same. But having said that, let's change the terrain the terrain surface. This one is just too bright. Let's have a look and let's make it contour triangle. This one here. So we have one contour triangle, which is this one here, one surface, and we have another surface which is like contours only. So now we got two surfaces here, but the reality is I don't need all this big area, because the area of work is much smaller than that. Let's have a look at see what we got here. So let's go that and look at the plan. Let's go to the plan and measure what's the size of this building. Okay, so by measuring the size of the building, and in this example we're going to measure the size of the blinding, which will give us an idea about the size of the building. So we go from there to there, and what we got here, let's say that's 18 meters, the width, and the length, what we got there is, so it is 18 meters by 27 meters. So let's transfer these figures into our earthworks model. I usually input the coordinates, exact coordinates of the building, so it will be plotted exactly on the model. But for simplicity, we're just gonna put the size of the building somewhere right in the center here with the right dimension. What we said is 18 meters by 27 meters. So let's put it somewhere there. So now we got the building, or in fact, let's move it a bit. Let's say move it a bit now, just to have a clear picture, somewhere right in the center there. Okay, so now we got two surfaces, and we got this shape here, which is represent the size of the building. So why did I plot this size of the building? Is for the program to work out the volume is it will work out to the minimum area. If we don't do that, it will give you the volume for the whole survey areas, which is much bigger than the building site itself. So the program will eliminate one of the services. Now let's pick the one which is the -150, and we will limit that into this area here. So now you will see now the surface of this triangular is only limited to the triangle, to the rectangular shape, where you got this surface against the surface of the whole area, but the program will work out the volume for to the smallest section. So now we achieve that. So what we do is we will work out basically the volume of the topsoil, and by going there and work out the volume between the two of them, and we'll give you the exact, which is cut 72 cubic meters. So if you want the schedule to be printed, we can, let's say, plot it here. As you see in this schedule, it does provide the unit of measurement in square meters and in cubic meters. But the bill quantity indicates that the unit measurement for the topsoil strip is in square meters. So it's basically is you can input, let's say you can input here 486 square meters, but we know that it is 486 square meters, but it is 72 or 73 cubic meters. The measurement cubic meters, it will be quite useful to pass on this information to the foreman of work, for him and the management to provide and to supply the site with the right plans. If it is a large scale project, we will know that we need bigger machines and a bigger transport dumpers to transport the topsoil to the allocated area. And that's the reason for working out the volume, for us to know what sort of plant, what machines, and what sort of resources we need to deal with the magnitude of the excavation and the disposal of this material. In the next tutorial, we will go more in depth with regard to the excavation and disposal of earthwork material. But for now, let's go back to the model and we work out volumes for the concrete and rebar and fabric mesh for all these items of work we got here. The first item is the RC pad foundation. So let's have a look at this item here and see how we're going to work out the volume for the rebar and the concrete. But first, let's isolate it. And as we can see here, it is the rebar and the concrete pad foundation. And there are four of them here in this model. So by looking, let's go back again now at the model. By looking at that now, by going into quantification, we can look for structural foundations, or slabs, or any reinforcement rebars, or any area where you are looking for quantification. So for our search now, we're looking for structural foundations. So you get to the structural foundation, then you come out with a few windows, giving you all these options of, for example, the type and the volume you need, and all the things you need to sort out for in your schedule. So having you done that, you come up with schedules, for example, like the foundations RC. So let's take this one off. So with the foundation, we got 4 numbers here, and what we are interested is in the volume of the concrete here, which is 11.84. And if you wanted to know the material of the which we used for this, whether it's C25, C35, or you need some information regarding the foundation depth, the width, length, we can get all that with our schedules. So let's have a look at another item. For example, this one here, which is the blinding. So what we call the blinding here? Well, we are interested in the volume of the blinding, which is 36.45 square meters. And basically, if you are interested in the area, and it is available as well, and many other information in the schedule. Yeah, so let's have a look at the fabric or the reinforcement in these items. So what we got here, we got this schedule is for the floor fabric mesh schedule. As we see here, we got a lot of information here with regard to the type, which is H10, which is the diameter of the bars, which is 10 millimeter, and the 12, 16, the bar length, quantities, reinforcement, volume. As far as the BIM is, what's available is within its programs is will give you the volume. But if you need to go even more in depth, for example, I like to have the volume quantity, the digital quantities, but I like it sometimes in weight, kilograms, or even sometimes in tonnage. So to do that, you can always work out, go to the properties there, and from any window we can get into, for example, this one here. We go to, for example, we go to the weight, and with the weight, you go there, and you see that we have a formula there, which is the reinforcement times the density of the reinforcement, which is the density of the reinforcement is 2,785 kilograms per cubic meter. So by multiplying the volume times the density, you will get the weight in kilograms, and by divided by another 1,000, you will get the tonnage. So in this example, we've seen the reinforcement being the volume is being worked out digitally and instantly. You got the volume, you got the weight in kilograms and in tonnage. Another schedule is being produced, which is the rebar schedule for RC foundations. It's the similar things. We got the reinforcement volume and the weight with the tonnage. But in this instance, we added another column here, where what we're saying is what we show, what's indicate that this is the total weight, but this is the total weight per one RC foundation. But the fact is we got 4 of them, so I added another column here which says the ground weight of 4 number kilograms, which basically is the weight in kilograms per 1 times 4. And we can see that basically by, as we said, by going there and looking for ground weight, the total weight for 4 numbers, this one here, and we can edit it, and we can see here is the weight times 4, as simple as that. So by doing that, you will get the total weight for 4 numbers of the reinforced foundation pads. So now we looked into how we work out the volumes for earthworks, with including the topsoil And as I said, hopefully in the next tutorial we can look into how we work out the volume for down to formation, foundations, and other items. And we looked into how to work out the volumes for concrete, for rebar, fabric mesh, and all these items which can be worked out instantly and digitally with modeling the project. And having done that, one final thing is we can produce a sheet here, sheet of work, and basically we can input put the view of the project with any other view, like for example this one, elevation, and on top of that we can pass on some information regarding this scheduling, like what you do here, 1 and 2, and you can organize them the way you like this being represented to the client or to the whole team and the management. And one more thing with digital quantification, if you make any changes to any item in the model, it will instantly revise the quantification for the whole project. For example, let's have a look at the reinforced pad foundations. We can see here the ground total, there are 4 of them, and the volume is 11.84 cubic meters. So how about if a member of the team or the designer decided to eliminate or delete an item? For example, we decided to delete this RC pad foundation. So if I take it off the project, and now we go back and have a look. Let me just to put that back again. We go back to the schedule and we'll see instantly the grand total reduced to 3, and the volume of the pad foundation reduced to 8.88. It's eliminated that item. So if I go back again and put that back again there, it will go back basically as it was before. Well, this will prevent recalculations and tracing all the new drawings and the updated drawings to update the schedules and volumes associated with it. So that means any member of the team, whether it's the designer, whether there are the engineers or quantity surveyors who they are using the model, any changes into that, any changes to any item, it will reflect instantly and dynamically on the schedule and volume of work. I hope you have enjoyed this tutorial and you benefited from it. And if you like